Now, if there wasn't already enough information for you to download into your grey matter on transition metal complexes, we do need to look at two different types of isomerism when it comes to these complexes. The first is bidentate complexes. Now, specifically these show a very specific type of isomerism that you have come across before. These bidentate complexes can show optical isomerism. All right. Now, you've come across optical isomerism before, hopefully in organic chemistry. So all those things that you learned about optical isomerism there, they do apply here, because what happens is it's working in exactly the same way as it does in organic molecules. So all those things you learnt about mirror image and non-superimposability and so on and so forth, they come to the fore here. Let me give you an example. I'm going to draw out here a copper complex that's got 3 bidentate ligands around it, okay? So it's the 1,2-diaminoethane, okay? So central copper ion, octahedral complex, that means 6 coordinate bonds, but 3 bidentate ligands around it. We've seen this before in the bidentate tutorial. Now, you might think, well, how does optical isomerism happen here? Because with organic molecules, it's where you have a central carbon and 4 different groups attached around that central carbon. Well, here, technically, we've got 3 groups, okay, because we've got 3 bidentate ligands. And if you remember, this is a 3-dimensional molecule. You can see how, that top 2 on the left-hand side, they're attached, bottom left, they're attached, and the ones on the right, they're attached. It's how they're attached to each other. What we do to show the optical isomer of this is show the mirror image. So that's what I mean when I say it works in exactly the same way as organic molecules. If you draw the mirror image of this, guaranteed you will get a different enantiomer or different optical isomer. The first part of the process, of course, draw your imaginary mirror line, and then you start with your central copper ion again, our Cu2+ ion, with it's 6 different coordinate bonds forming an octahedral complex, and all are NH2s. Now, that doesn't change because all of them are NH2, right? But where each of them are attached to each other, that does change. So that's where we need to show our mirror image. So we look at the one on the other side and we make sure that we draw a mirror image here, okay? So we can see that, okay, it doesn't look that different, but it very much is different, okay? So if you look at the optical isomer of this, it is a mirror image, and of course, they're non-superimposable. Of course, we mustn't forget that there's a 2+ charge as well, okay? So that's the one example I'm going to show you, because you know what? I think that's all you need to do to show the fact that these bidentate complexes do show optical isomerism. Now, another thing that's similar to organic is that we can call these enantiomers. So this could be enantiomer A and this could be enantiomer B. I've shown you an example using that 1,2-diaminoethane, but this can also occur with any bidentate ligand, even ones you've never seen before. But the two other examples that we have talked about already are the oxalate ion, the C2O42-, and of course that 1,2-diol benzene molecule, okay, so benzene 1,2-diol. So it can happen with those two. It doesn't matter what the bidentate ligand is, so long as they've got 3 bidentate ligands around in that octahedral shape. There's a few things I want you to remember, linking it back to what you should already know from the organic chemistry side of things when it comes to optical isomerism. The first is that these 2 optical isomers, they're non-superimposable. If you want to draw the 2 isomers, then you go ahead and draw the mirror image, just like we did before. Just like our organic molecules, they will rotate plane polarized light. And lastly, of course, it is possible to have a racemic mixture. And if you remember, that is where we have equimolar, really important word, concentrations of both. So lots of things from organic chemistry in terms of optical isomerism apply here, but just remember, this is where you have bidentate complexes and they give optical isomerism, and that's it, just optical isomerism, and they show that obviously looking at the mirror images here. So linking to organic, but of course this is very much inorganic chemistry and specific to bidentate complexes. Make sure you subscribe to our channel so you can keep up to date with all our new content. If you like this, you'll love our free trial. Click the link and check it out. You've now got 2 choices. You can wait and see what YouTube randomly throws up, or you can improve your grade in under an hour by checking out my awesome chemistry transformation playlists.